Hello, this is Ms. DB, and today's we are going to learn about Chapter 6, Section 2 on properties of parallelograms. You should take some notes because there's lots of properties of parallelograms, and they will come in handy for the rest of the chapter. Our objectives are to prove and apply properties of parallelograms, and then to use these properties to solve problems. Parallelogram is our only definition, and a polygon with four sides is a quadrilateral. Any four-sided polygon is a quadrilateral. But some of them have special properties, and they get special names. And the one that we're going to learn about today, of course, is a parallelogram. Opposite sides of a quadrilateral do not share a vertex. Opposite angles do not share a side. Try to keep that in mind as we go through these properties. So here's our definition of parallelogram. It has two pairs of parallel sides. To write the name of a parallelogram, you use this symbol. However, it's very hard to make that symbol in Word or when typing, so we usually just write out parallelogram then. Here's an example of parallelogram ABCD. It has, remember, two pairs of parallel sides. Opposite sides are parallel. So in this one, AB is parallel to CD and BC is parallel to DA. Our first property is that if a quadrilateral is a parallelogram, then its opposite sides are congruent. So in addition to having opposite sides be parallel, the opposite sides are also going to be congruent. So AB will be congruent to CD, and BC will be congruent to DA. We have more theorems. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So in this picture, angle A is congruent to angle C, and angle B is congruent to angle D. In 623 theorem, it says if quadrilateral is a parallelogram, then its consecutive angles are supplementary. So if we call this angle 1 and this angle 2, angle 1 plus angle 2 is equal to 180. So the measure of angle A plus measure of angle B is 180. The measure of angle B plus measure of angle C is 180. Measure of angle C plus measure of angle D is 180. And measure of angle D plus measure of angle A is also equal to 180. So these two add up to 180. These two add up to 180. These two add up to 180. And these two add up to 180. If a quadrilateral is a parallelogram, then its diagonals bisect each other. That means that BZ right here is congruent to ZD, and AZ would be congruent to ZC or CZ. So the diagonals bisect each other. They cut each other in half. So all kinds of those things are true if you have a parallelogram. All right, so we are given that CDEF is a parallelogram, that DE is 74 millimeters, DG, this little piece here, is 31 millimeters, and the measure of angle FCD, right from here to here, is 42 degrees. And first they want us to just find CF, this side right here. Well, opposite sides are congruent if you have a parallelogram. So that means that DE is equal to CF. So CF is going to be 74 millimeters as well. Now, if you're asked to find the measure of an angle, in this, let's see, FCD, this was 42 again. And if we're asked to find EFC, we're asked to find this. Well, we know that these two together are supplementary, so they add up to 180 degrees. So we would subtract the 42 from 180 to get that the measure of angle EFC is equal to 138 degrees. And now we're asked to find side DF. That's this diagonal. We know that DG is 31. We know that DF was bisected by the other diagonal, which means that DG is congruent to FG. Or we could just take 2 times 31, or 2 times DG, to get the whole thing of 62 millimeters, I guess this is, millimeters. All right, here we have kind of an application problem. We have this parallelogram that holds this basketball hoop up so that you can raise and lower it kind of. We have one just like this outside of our window. And we know that LM is 28 inches. We know that LN, that's the whole diagonal, is 26 inches. And we also have measure angle LKN. This angle down here is 74 degrees. So we'll be asked to do several things. The first one is KN, this side over here. Well, that's congruent to LM, so that's the easiest one. That's just going to be 28. The opposite sides in a parallelogram are equal, so it's 28. Okay, the next thing that we're asked to find is the measure of angle NML, this angle up here. Remember that LKN is 74. Well, in a parallelogram, opposite angles are congruent. These aren't supplementary. They're just going to go ahead and be equal to each other. So if you know that the one angle is 74, the angle opposite is also equal to 74. We're asked to find LO, which is this piece of the diagonal, when the whole diagonal is 26. Remember that that diagonal is bisected by the other one, so its LO would be half as long as the whole thing. So if you take 26 divided by 2, you'll get 13 inches. All right, in this problem, we're asked to use properties of parallelograms to find measures. And please make sure that you know whether you're finding an angle measure or the length of a segment. If we're asked to find YZ, this is a segment length. So we are not going to use the parts that have to do with angles. These have little degrees on them, so I know I'm not going to have to worry about those. I want to find this side. I know that 8a minus 4 is equal to 6a plus 10 because in a parallelogram, opposite, not angles, opposite sides are congruent. So YZ is congruent to XW, which means that their lengths are equal. And then we can plug in 8a minus 4 equals 6x plus 10, and we'll solve that from a next. So let's see, I'll subtract 6a, and I'll get 2a minus 4 equals 10. Add 4, and you get 2a equals 14. So a is equal to 7. And once we know that a equals 7, we can plug that into the expression for yz, which is 8a minus 4. So 8 times 7 is 56, minus 4 is 52. Now in this question, they're asking us to find the measure of an angle. So then I will use these ones with degrees on them, and I won't use the ones that don't have degrees on them, because those are referring to sides. So this 9b plus 2 is for z, and 18b minus 11 is for w. Well, remember that these two added together are supplementary. In a parallelogram, consecutive angles are supplementary. So I can write that 9b plus 2 plus 18b minus 11 is equal to 180 degrees. And then we'll combine our like terms, and 9b plus 18b is 27b, and 2 minus 11 is minus 9. Add 9 to both sides, and then divide by 27. And we end up with b equals 7, and they want us to find the measure of angle z, so then I'll take and put 7 in for b. 9 times 7 is 63, plus 2 more would be 65. All right, when you are drawing a figure in the coordinate plane, the name ABCD gives the order of the vertices. All right, so we have 3 vertices of parallelogram JKLM. Do they draw a picture of this? Yes, they do. Good. Okay, so they graphed J down here and then K. So J and K have to be connected to each other because they're in order. And then K will be connected to L. And we don't know where M is. That's what we're supposed to try to find. So M we can figure out is going to be somewhere over here. So we know that opposite sides must be parallel. So I know that M is going to be somewhere over here. I know that KL has to be parallel to JM, and KJ has to be parallel to LM. That's going to help us because if I could find the slope from K to L, let me draw that line back in there. So the slope is rise over run. So I'm going to go 1, 2, 3, 4 is my rise. And my run is 1, 2, 3, 4. Is it 4 and 4? So my slope is 1. 4 over 4 is 1. That means that the slope of the other side opposite also is going to be 1. So I can go up 1, 2, 3, 4, and over 1, 2, 3, 4. Or I could have just went up 1, over 1, up 1, over 1. And this is where m is going to be, up there. So that's got to be my vertex, 7, negative 4, because that's where I ended up. So I really don't have to do anything else for this problem. You can just say that is got to be m. However, you could verify it by making sure that LM is parallel to KJ by finding the slope of those two lines too. So they did that, and they found that the slope of LM would be negative 2, because the rise, let's just go from this point to this point. So the rise is 1, 2, 3, 4, and the run is 2, and it's going downhill, so that's a slope of negative 2. And then over here, a slope of KJ is the same thing, down 4 over 2, which is a slope of negative 2. So they both have the same slope, so therefore we were right about our coordinates for m. That would be 7, negative 4 would be the fourth point in our parallelogram. Sometimes you're asked to write a proof using the properties of parallelograms. You won't have to do this very often in this chapter, but there will be a couple proofs on the worksheets here and there. In this one, we are asked to prove that triangle AEB is congruent to triangle CED. So remember what we need to show that triangles are congruent. We can show that all three sides are congruent. We could show that an included angle between two congruent sides is congruent. We could show, what else do we have? Angle, side. We have angle, side, angle, or HL, which won't work for this one because it's not a right triangle. So let's see what we got. We got a parallelogram. We've got, we know that opposite sides are parallel, right? Because it's a parallelogram. That's the definition of parallelogram. We also know, because it's a parallelogram then, that opposite sides are going to be congruent to each other. So we know that AB is congruent to CD. Well, remember, these are the two triangles I'm trying to prove equal, so I want to find parts of those two things that are congruent. So that's definitely a good one. We also know that the diagonals bisect each other because of, that's another theorem we learned. So that means that BE is congruent to ED and AE is congruent to EC. Well, I've already got that the two triangles must be congruent by side, side, side. So that's all we would have to do to prove that these two triangles were congruent, knowing that we have a parallelogram there. So that wasn't a bad proof at all. Okay, here's another example of a proof. Let's see if we have to do anything else. We are given that GHJN and KJKLM are both parallelograms. We know that H and M are collinear. That means they lie in the same line. N and K are also collinear. And we want to prove that angle H, where's angle H? Angle H is congruent to angle M. All right, so here's what we're trying to prove here. Our first thing is we would write all that, as much of our given in that we need, so we know they're parallelograms. And from that, we know that angle H and HJN, this angle here, we know that they have to be supplementary, because that's part of one of the theorems about a parallelogram, is that consecutive interior angles are supplementary. But we also know that angle M will be supplementary to, I don't want to use the same markings, but this one and this one are going to be supplementary for the same thing. It's also a parallelogram. But we know that these two angles are equal to each other by vertical angles. So now I can take away this kind of strange way I had of marking it and just put the same thing. They're congruent because they're vertical angles. Well, that means that angle H must be congruent to angle M as well, because of the congruent supplements theorem from way back when, that says that if you have angle H is supplementary with angle HJN, and angle M is supplementary to KJM, and these two angles are congruent to each other, then these two must be congruent to each other as well. And we've already proved it. So it wasn't a very long proof. We did have to kind of go back in time to get a couple of those theorems, though. All right, so I hope that you have a good time doing this worksheet. Parallelograms are kind of a lot of fun and very useful, lots of different proofs, and we will continue working with parallelograms for the next few sections, so you're going to get really good at them. Let me know if you have any questions. Thank you very much.